for tomorrow's session. Like Mr. Nambanis indicated that we are going to start with the topics that we think it will benefit learners, like indicated in intermolecular forces, Newton laws, statics, and electric circuits. So I think to move faster, I'm going to use the past question papers because Tata Nambani, can you see it? Can you see it that side? IMF. Okay. Okay. So now we talk about the intermolecular forces. So these are the forces between the molecules.
Sir, can you please flip paper? Please put it horizontally. Maybe we can be able to see properly.
Okay. All right. So intermolecular forces. Can you see that Nambani? All right. Thank you very much, colleagues. Now, the intermolecular forces, these are the forces between the molecules. So now, talking about the forces between the molecules, I can have an example of the water molecule. So if I need to draw the structure of water molecule, so that will be the structure of water. Remember, water must be bent. I can have another water this side. I can have H and OH. So now between these molecules, so you talk about the intermolecular forces, referring to between the an oxygen atom. This one is intermolecular forces. So this one is stronger than the intermolecular forces because the intermolecular force the three phases of matter. So we know that I'm having solid, and now I'm going to have the liquid, then as well as the gas. So I'm going to make an example by using the ice. Now the ice, we know the molecules are closely packed. They can also take the shape of the container. Then now to move from the solid to liquid, we know it will be the melting point. So, but now for this ice to melt, it needs certain temperature. So from the liquid to gas, so we know that will be evaporation. We're going to talk about the boiling point. So the particles are also closely packed, but not as you compare to the solid phase. What about the gases? The particles are far apart. So now from between the solid and the liquid, we're going to talk about, we have the strong, we're going to talk about the strong intermolecular forces there. But if you look at the gas, the molecules are far apart. So we are going to talk about the weak intermolecular forces. All right, if this is a strong intermolecular force, to break the ice, meaning I need the energy. What type of energy? Is it more energy or less energy? So in terms of energy, we are going to talk about the energy. So because this one is a strong intermolecular force, I'm going to use more energy to break the ice. So I'm going to talk about that part later. What about this side? Because this is a weak intermolecular force, so what about the energy? I'm going to use less energy now to overcome the intermolecular forces. So this is where you're going to start. We have the boiling point. Let us look at the boiling point, which is the BP, as well as the melting point, as well as the vapor pressure. So the three concepts, so you must be able to define what is the boiling point, the melting point, and vapor pressure. So the structure, let me start with the boiling point. The boiling point is in proportion to vapor pressure. So now you need to know this part. If the structure is having high boiling point, it simply means now the structure is having the low vapor pressure. Now the melting point, it will be the same as the all right, thank you, Tate. So it will be in proportion to vapor pressure. So we know if the structure is having low melting point, as an example, I'm having high vapor pressure. All right, the types of intermolecular forces. Then we'll go to the types of intermolecular forces. So now, if I start with the induced dipole forces. So this induced dipole forces, we can say this is the dispersion force, or you can say London forces. But for now, I wanted to stick on that induced dipole forces. Where do we get it? Between the non-polar covalent bond. So now non-polar covalent bond can have BR2, we can mention them. There are so many. I think colleagues, we have done that one with our learners. So between, because this is a covalent bond, is to share of electron. This one will be hydrogen together with hydrogen. This is going to make a bond. So now, this is the London forces. London forces, we experience the force of repulsion because this side is partially positive and that side is partially positive. So positive and positive, they're going to repel. So that will be the non-bond, even if they calculate the electronegatividity difference. So it will be, you check the electronegatividity. We go to the periodic table. For hydrogen, I'm having 2,1. So it will be 2,1 for hydrogen minus 2,1. So we get 0. So this one you are saying is the pure non-polar. So we know if you talk about the induced dipole forces, this is between the non-polar covalent bond. Then now I'm having dipole forces. So the dipole forces is stronger than that one of induced dipole forces. Where do you get this one? Between the polar, if I'm having covalent bond. So an example, if I'm having HCl, I know the HCl there is a force of attraction. There's a force of attraction. So we look at the electronegatividity. Now, the electronegatividity difference, the chlorine is 3,0, that one is 2,1. So we have what we call electronegatividity here. So the greater the electronegatividity, meaning which is chlorine, is going to attract that one. So that will be direction. So meaning hydrogen, it will be attracted towards the chlorine. Why? Because of chlorine, if you're referring to the electronegativity strength, chlorine is greater than hydrogen. So this is a polar covalent bond. If it's a polar covalent bond, we have what to call the dipole forces. Then I can move to the third one. This one is an hydrogen bond. Okay, the notes okay. Okay, so, okay, okay. Okay, thank you, sir. The induced dipole forces, where the induced dipole forces is when I'm having the non-polar covalent bond. So the non-polar covalent bond, I made an example by using H2, hydrogen and hydrogen. It can be Br2, the bromine, and also this one of the Br. So it's an halogen. This one is partially negative. Even this one is negative. So they're also experiencing the force of repulsion because of what? Negative and negative, they repel, but this one is positive. Even this one of hydrogen, positive and positive, there's the force of repulsion. So now to calculate, if the question is saying, now use electronegativity to explain why this is non-polar covalent bond. So you're saying the electronegativity, you go to the periodic table and you check the electronegativity for hydrogen. Hydrogen is 2,1. So is 2,1. Electronegativity for hydrogen, it must be minus the change in electronegativity, En, electronegativity is 2,1 minus 2,1, so we get 0. So this one is some of the textbook they're saying. All right. Then now the second one is dipole. Then now the second one is dipole.
Um, negative. Negative.
Okay, I will do so.
This meeting, will it appear on YouTube?
Mr. Nambani, apparently the same problem that took place during the beginning of this has occurred again. So I advise them to use the phone instead of using the Wi-Fi at the school, because now they are wasting the time, because now the electricity keeps on tripping at the school. So now they're trying to use the phone to hotspot using the phone. So we humbly apologize for inconveniencing your colleagues. Thank you.
The screen, you can see my screen, Mr. Manambane. Okay, Mr. Nambani. All right, the second one is dipole forces. Now, the dipole forces you find between the polar covalent bond. So, in hydrogen is group 1 in the periodic table, group 1, group 2, group 3. Those, although we know that hydrogen is non-metal, because non-metal and non-metal, it will be a covalent bond. Then now hydrogen is partially positive, and also chlorine is partially negative, that side. So once I'm having positive and negative, I'm having the force of attraction. So it will be the polar, it will be dipole forces. So the chlorine, because of electronegativities, is greater than hydrogen. So now the chlorine is going to attract the hydrogen. So the molecules as a whole, it will be polar. Then you say it's the dipole forces. It will be dipole forces. Now moving to the third one, hydrogen bond. So hydrogen bond. Third one is hydrogen bond. The hydrogen bond is correct. The hydrogen bond was Matapelo.
This stream live on YouTube. Like, how do we search it? We search what?
Okay, Mr. Nambane. The hydrogen bond. The hydrogen bond. If you see hydrogen bonded to either nitrogen, oxygen, and the fluorine. So we know definitely this the type of intermolecular force present there will be hydrogen bond. An example, I'm having H2O, so meaning the type of intermolecular force is hydrogen bond. Then if I'm having NH3, because this hydrogen is bonded to nitrogen, NH3, so definitely this is going to be the hydrogen bond, and I'm also having HF that side, so it will be also the hydrogen bond. So I don't think this one is difficult. It will be easy once learners they remember. Once I'm having hydrogen bonded to nitrogen, oxygen, or also the fluorine, the type of intermolecular forces, it will be hydrogen bond. But if you look at this one of what we call the ion dipole forces, so the ion dipole forces is stronger than others, even stronger than hydrogen. An example of the ion dipole forces, I can make an example by using
Mr. Nambani, will you kindly attend to the, while you're still waiting for Mr. Karume to connect to attend to the questions? I see the hands.
Just saying, say we can hear.
Sir, can you please tell Mr. Sekhakume to lower the link because we can't see.
Could you please send the link whereby we can watch it on YouTube, because the network of this on this platform, it's not really working for me. Yes. Thank you very much.
Yes, we just want to ask, Mr. The one who is still representing, yes, is he still going to present physics part, or it's only chemistry? If not, maybe since network it's giving him difficulties, why can't maybe as someone take over to present physics, then he will maybe finish off after. And this is the question, so that because the learners are writing now at 1, and is it 1? There's a second session, they're writing Sesotho, and it's also a common paper. So I'm worried about the time. No, thank you. Thank you.
I wanted to ask the same question that was asked. Thank you. I wanted to ask the same question that was asked. Thank you. Mr. Thor.
So we are asking if are you done with chemistry or Okay, guys, I would like to apologize for what is taking place now. Mr. Nambani will start with the Newton's laws of motion. Just try to revise while we're still trying to get hold of Mr. Sakharume, and then when he's done, Mr. Sakharume will join us. So over to you, Mr. Nambani. You can continue. Thank you.
Thank you very much, ma'am. Just sorting out. Says I just need confirmation that you guys can clearly see my screen. So I'm going to somehow do a summary
we
of
can.
everything with a little bit of a question here and there. So with that being said, let me just sort out this station that I'm going to use, and then I will be with you in the next. Ladies and gentlemen, welcome once more. I am Mr. Nambane, like I said. Sorry for any inconvenience that has been caused, but we are trying now to solve that particular issue. So let me quickly take over without wasting any time. So what I will be doing from my side is very easy. It's just an issue of explaining few concepts that one believes that now we need to start looking into, especially now when we work with Newton's laws. But now, like I did explain the demarcation thereof. So from the demarcation itself, I'm also going to try and be slow. The thinking here is we look into the topics that have a certain number of marks. That is the reason why immediately when this challenge that we're experiencing within Ntate Srarume, the idea is let's kindly now quickly look into the Newton's Newton's laws. So I'm going to explain key critical things that one needs to look into in order now for one to actually get maximum marks. But this is a lesson that I recorded previously. So I'm just going to now further emphasize on it. But let me get a new sheet for me to be in a position of explaining exactly how one intends on explaining some of the concepts here. So let me quickly just remove this and say now with Newton's laws, ladies and gentlemen, with Newton's laws, this pen is too thick. With Newton's laws, like we said, it will be plus minus the 35 marks in an exam. But now the 35 marks comes from one actually understanding few critical important things. One that we need to be looking into, it's now the definitions thereof. But now which definitions are more critical? The very first one it will be what is now a normal force. The other one thereof will be now what is frictional force. And now with frictional force, it's two important definitions also that one needs now to also understand and follow through. It is what we call now static friction, as well as now kinetic friction. So these two forms now part of the frictional force itself. So it basically says now when I sit down and prepare for tomorrow, these two critical definitions have now a direct link with now one another. Why do they have a direct link with one another? They have a direct link with one another only because, ladies and gentlemen, only because when we check the equation, we'll say Fs mu s normal force. Fk is equals to mu k F normal or normal force. So this is only now because of what? Because of the relationship that we have between the normal force as well as the frictional force. So the expectation is if the examiner now decides and asks a question that relates to frictional force, the expectation is we expect now to have an application of now what? The application of frictional force and the normal force. Why is that the case? That is the case now because from the formulas itself, we can easily now pick up the involvement of F normal, the impact now of F normal. But I must also say, maybe under the normal force also, to say, let me take this normal force and bring it down here. Normal force. But for me to explain this normal force in detail, there are situations where we are going to have on a frictional surface and a force applied in this particular direction. We are going to have a situation also where we have our frictional force, but the force now applied at this particular direction. And lastly, we are going to have now an object that we say, I should have used my science here, but no problem. That we say, but fine, this one now it's sitting on an inclined plane with now also the force applied. But what is the challenge? Majority of us now, we don't want to apply the rules of a free body diagram. So a free body diagram will assist us in order to do what? In order to actually be in a position of explaining exactly how will now the equation change in terms of calculating the normal force. So the very first one is, let me draw a nice simple free body diagram. I must just use the tools that I have to ensure that I actually draw the right one. Let's fill it now with black and use arrows, because remember, it is only a correct free body diagram provided that you have now your arrows, and remember they must touch the dot. So I'm quickly going to draw here and move now this one a little bit lower. And in this position, one can easily say, provided that I have now the correct free body diagram, it becomes easy to say this is my force applied, this is now my force normal, and this is my FK friction, and this is my FW. But now, because of this, ladies and gentlemen, I'm going to take your questions. I see hands. I know I'm a little bit faster, but I'm just trying to catch up with time. So it basically says, ladies and gentlemen, in this instance, one can easily say now Fn is actually equals to Fw, but the Fw is equals to mg. That is now one of the problem that we are experiencing, especially when we mark questions that relates now to your normal force. So with that being said, can it be the same now for when an object is actually pulled at a certain particular angle? Let's draw a free body diagram. And this is where now the majority of mistakes comes in. You have your normal force, your FW, you have now your force applied, you now also have your frictional force. Let me quickly label. This is your FA, this is your FN, this is now your FK, this is now your FW. But now what is the challenge here? Fine. Now, the people who are setting these papers said we do not want components as a free body diagram, because now it will say now draw a free body diagram. So when you draw a free body diagram, it basically says they want to see the actual forces that are now what? That you are actually having as part of your free body diagram. But that does not assist us in terms of the calculation. That does not help us in order for one to get the desired total amount of marks. Why? Because, ladies and gentlemen, when you look into the one that I'm going to draw quickly with components, I am going to have my F normal, F normal, also now break it down into its components, which will be now FH. Let me move, which will be FH. Let me make a very big dot. Then this is FV. Then this will be now FW, and this will be FK. So let's now, in the next 10 seconds, just digest the free body diagram as I attend now to Ndates Kharume. Just for 30 seconds, let's digest this particular free body diagram. I am busy with Newton's laws. Now join the meeting, settle, and then once you are done with that, I will give you a platform to do so. But join the meeting so long. Thank you very much, ladies and gentlemen. I was just attending to issues of Ndates Harume. He will be joining us again. But now that I have started, let me continue until I finish everything that is now Newton's laws. Colleagues, this is, and learners, this is an opportunity now for you to ask me a question. By show of hands, I've seen hands, so I wanted to now to take those particular hands, but I don't see them anymore. Maybe I did explain that. Now, ladies and gentlemen, the trick here will be which forces, referring to whatever the examiner is going to ask. But if the examiner now wants me to use the information of F normal, it basically says, because we are working with vectors, I'm going to decide and choose now upward as positive for me. Then it basically says Fn plus now Fv should be equals to F normal. But now when I check Fn is equals to, sorry, this must be Fw. Let's remove and quickly say this is Fw. So Fw minus Fv is actually what is now Fn. Hence, I said now the Fn will forever change and depend on the information that is given. It is not always now equals to F is equals to mg. It changes per the expression that we have per free body diagram that we have. But I must highlight, let me use this, I must highlight that now this, ladies and gentlemen, it's now only for the purpose of calculation. We do not want to see a free body diagram with the components in an Excel. Adrenalina, how best can I help you? Questions, please. Adrenalina, yes.
I can't see the presentation. I can only hear you talking.
You don't see the screen?
Yes, sir.
Can somebody else also say they are not seeing a screen? Then I will know that the challenge is on your side. Can somebody just quickly confirm? You can see. Thank you very much. Then Adrenalina, the best thing that you can do is maybe then just maybe move.
We can see you, Mr. Nampani.
Thank you very much. Just now, go out and come back. Maybe you have issues of seeing the screen, but for everybody now, just confirmed that they can actually see me. Not me, but the screen. Thank you very much. Why do we not want the one with components? Because the examiner said, draw a free body diagram. The other question that just quickly came in is, what if a learner uses components in their free body diagram? Are they going to lose marks? Yes, Mira, they are going to lose marks. The reason why, the emphasis now, remember back in the day, we would, was the word, we will accept the components. But now lately, DBE said, let's not accept the components because the components, they actually represent a specific force. They are not necessarily a force that actually takes place or being applied in that particular situation. So let's encourage our learners and also the learners that are here to say, fine, we are only going to draw the one that actually indicates the forces. When we want to draw the one with the components, how are we going to do this one? Very easy. We are going to do this one on a separate answer sheet for the purpose of calculations. Because now when you check this free body diagram, this one here. Let me take a pen, sorry. When you check this free body diagram there, it will not give you this particular section of VW, or sorry, FW. So because of that, majority of you learners, you are going to lose marks. Majority of you, you are not going to get it right in terms of now. Immediately from this, the expectation is we are going to use this particular equation into either one of the two given in order for us to get the frictional force, which will then come into a play of explaining Newton's second law. I see a hand there from Ayanda Mahailani. Kindly ask your question so that I can move now explaining other important concepts. Ayanda?
About your free body diagram, I could see that you used kinetic frictional force at the first two, actually all the three diagrams. So now I'm confused because is it because the object is not moving? Aren't you isn't there frictional force? Because at school we use F as and that F with a cursive writing. Or is it, can I say frictional, I mean static friction instead of friction kinetic? I'm a bit confused there.
Okay, let me attend to your problem. There's always this thing here. I'm going to write it down. Maybe I should have just maybe indicated direction of motion. Let's just say this is the direction of motion. It basically says now all these particular objects are actually moving. That is the reason why I opted now to say, because my thinking is at some instance, I want to apply the very same principles to Newton's second law. So the thinking is now let's have this object moving. That is the reason why I have FK for kinetic friction. If it was stationary, it will be Fs because of static friction. So now the question that you are asking is, somebody will just use the cursive F. Somebody will just use F or FK, and then others will write friction. So we accept all of them. Okay. As long as now they are associated with now what? The correct direction of that particular force. So every school, every teacher has their way of doing things. But for me, if it's just F now, when and how will I be able to distinguish whether I'm referring to static friction, whether I am referring to kinetic friction? So that is the reason why in my free body diagram already, if I am told that now the object is in motion, then automatically I just now refer to FK. If it was stationary or at rest, I refer to FF. But if it's just F, to me, it is still correct, yes, but it doesn't necessarily put more emphasis into the actual understanding of static friction and kinetic friction. I hope I have answered you to the best of my abilities.
Yes, sir. Thank you very much.
Thank you very much. Ladies and gentlemen, let's quickly move. Then just lower your hands so that I can be able to see the new hands that are coming in. Now, with that being said, it basically says now I need to assign geometric expression to this particular free body diagram of mine, because the thinking now is this particular force, it is applied at an angle. So if it is applied at an angle, then this will be just F sine of theta, and this will just be F cos now of theta. Then it means I must come now into this particular equation and say FW minus now F sine of theta. data. This becomes now a standard way or a standard approach. But remember, questions will forever change. The examiners always try to improve the skill or questions of yesteryear to the recent now issues of what is it that is challenging learners. So majority of you have challenges when now we start applying a force at a specific angle. Furthermore, I am going to say now, let's try and check now for this one of an inclined plane. Let me get my sketches here, draw a nice free body diagram, fill it now with black. Let me have my force moving up there. Let me have my force also moving up there, which is force of friction. And I have my normal force, which is defined as now a force that acts perpendicular to the surface. And then I am going to have my FW now, which is acting downwards. Easy 4 marks. Also, F applied, F normal, FW, and now FK. Easy 4 marks. But this, ladies and gentlemen, is not going to assist me in order to get now the maximum marks that one desire. And most of you, you'll forever have a mistake of your forces not aligned according to the direction of the plane. So ensure that your forces, your FA is parallel to the surface. Your FK is also parallel to the surface. Why, ladies and gentlemen? Because as a definition of what is a frictional force is a force that opposes the direction of the motion and it is parallel to the surface. So in this instance, if it is not parallel to the surface, automatically we will be starting now losing a lot of marks. Before I can go to you, Mr. Mtau, let me just quickly say, fine, can I be in a position of resolving this into its components? Yes. Why into its components? This is what I am giving the examiner. Let me use purple. This I am going to give to the examiner. This is now my perfect answer, 4 out of 4. But I need now the one with components for the purpose of calculations. So while I attend to Mr. Mtau, kindly just now reminisce and think of how best can one be able to draw this one into its components. Mr. Mtau.
Do we round off while we are calculating or we don't round off at all?
I cannot hear you, Mr. Mtaun. Your background is very noisy.
Sorry, sir. Do we round off while we are calculating or we don't round off at all? Before reaching the final answer.
Mr. Mtaun, can you kindly just maybe type it? Then I can be able to read and follow you because now I cannot hear what you're saying. Thank you very much. Thank you. Thank you very much. Unfortunately, I want to answer you, Mr. Mtaum, but I cannot, only because of now your background is too noisy and I can basically not hear you. Let's move. I thought maybe you took that 5 seconds to actually draw the one with components. So I am going to do it on my side quickly. The one with components for the purpose of explanation. I am going to draw now this one, which is FA. have now this one, which is FK, make a very huge dot for me to be able to accommodate FG parallel, and have now there my normal force, and have there my FG perpendicular. Okay, fine. Now I want information relating to the normal force. What must one do? The only forces that will take part into that particular calculation, it's this ones. The relationship now between FG parallel, FG perpendicular, or a component of a force relating to that. Noted, Lebohang, let me just basically attend now to this particular issue. It's easy now. From the free body diagram, one can easily say Fn now is equals to Fg perpendicular. Sorry, yes, Fg perpendicular. And it means Fn, ladies and gentlemen, will be just mg cos of theta. Yes, mg cos of theta. This now is what I am going to use when I have a situation of an inclined plane. That is going to assist me to be able to say mg cos theta, and then this one here will be mg sine of theta, where theta, ladies and gentlemen, is actually this angle here, the angle of inclination. Lebohang? Lebohang? Kindly ask your question or inputs, please.
May I please ask why you drew the components of the gravitational force this way? Because I am a bit lost.
What do you mean this way? Maybe explain that. How do you know it?
Sir, on the first
Yes.
body that you drew, I can see that the gravitational force is pointing down. And on the second one that you drew, the gravitational force perpendicular is opposing the normal force. That's the question that I'm asking. Why is it that way?
Oh, okay. It will have to take us back to vectors of grade 10 and 11, but basically that is how it is. Because of issues and purposes of time, I will not go into that, because remember, you must draw a, wait, let me just, you must draw a line here. Let me use red. You must draw a line there and something like that. And then it becomes, it's complicated science, lady. So for now, let's just basically say Fn in a situation of an incline, it will be equals to Fg perpendicular, which is equals to mg cos theta. The science related to that of drawing a diagram there and there for you to be able to actually now draw the correct one in terms of when and how can you know that you are going to have the one that is parallel or perpendicular there and the one that is parallel. It's complicated science that I am not going to bother you with for now. Kindly be patient with me. So for tomorrow, such that you do not get confused, just remember, if it is on an inclined plane, then your normal force is actually equals to the perpendicular component of the weight, which is just now mg cos theta. Follow up, Leboha.
Okay, I get it, sir.
You get it. Thank you very much. I'm very happy. Remember, the exam is tomorrow. So with that being said, as long as you understand where it comes from, and I don't want to bother you with that because it will not be asked in an exam. So the only thing that you need now to worry about is, do you know that if it is in an inclined plane, F normal is actually equals to F perpendicular. This is me trying now to actually show you the mistakes that now we move with understanding the normal force and apply into Newton's second law. That is where the challenges and problems comes in. There's a question in the chat. Let me quickly try and answer it. It says, do we assume that the object is stationary? No, we do not assume that the object is stationary. Hence, Ntate Nambani highlighted to say it is important now here for me to indicate the direction of motion. So the direction of motion, I said it is moving upwards. And I said for this one and that one, this one and that one, which are those ones? Okay, let me make it easy for one to follow. For diagram A, they're moving horizontal. For diagram B, they're also moving horizontal. And then for C, they are moving up the slope. Hence, I did indicate now the direction of motion. Ladies and gentlemen, feel free to ask your questions while I try to duplicate this particular page for me to add other important things. So I'm going to give you your 30 seconds to digest and think of everything that we spoke about here. Just 30 seconds for one to actually digest everything that we spoke about. Remember, this is not a teaching session as in you will do it in your school. It's actually just a quick way of revising and seeing the pattern of what to expect in an exam. Ayanda?
Sir, next to Fn is equals to F gravitational force. The FV, what does it stand for? I'm a bit confused there.
The F where?
FV next to FW minus FV.
Oh, the FV is for the vertical component of that applied force.
Oh, okay.
So then the F is for horizontal component. Other teachers uses FY, that will mean basically vertical. Other schools use FX also, that will also mean horizontal. So it's just now the interpretation that now each and every one teacher has that relates to this particular.
Okay, sir, thank you very much.
Thank you very much. Ladies and gentlemen, without wasting any time, let me quickly now move. I have duplicated this particular sheet. Now I'm going to try and apply these basic principles to Newton's second law. You are noted Yakisizwe SS, you are noted, will be with you in a couple of seconds, just sorting out the system here. So basically, ladies and gentlemen, what is going to happen here will be, we are going to, let me remove all this. We are going now to take the very simple principle and try applying it to Newton's laws. Because now Newton's laws, ladies and gentlemen, it's an easy basic concept that now all of us must be able to get maximum marks. But before I get into now bullet number C, which will link what we said here on bullet number 2 and 1, relating Newton with the frictional force. Yakisize, the platform is yours, while now I try to move into Newton's laws. Yakisize. Yakisize. Seems like now Yakisize doesn't want to say anything. Tshebeletso, quickly, says that we save time and we'll be able to attend to other important topics as well. Tshebeletso, also gone. Ladies and gentlemen, let me just now lower the hand of Yakisize so that I can be able to see new hands as they come in. Let's move, ladies and gentlemen, to this other part. I want to put my head on the block and say, yes, we are going to have Newton's first law. Newton's first law. But history and experience has taught me that this will come as either multiple choice question or will either just come as application. But the application here will be now for the safety of airbags, safety now of seat belts, also relating that to first law, and maybe an issue of inertia thereof. There are no calculations relating to this particular law. So expect to get something in Newton's first law as a question in multiple choice, or the application in safety belts, and now the basic principle of inertia. Then that will become now an easy way of 2 marks or 3 marks here and there, but we do not have to worry that much about Newton's first law, because what does it say? What does Newton's first law say? It says an object will remain at rest. So if it is at rest, it basically says Newton's second law will not be applicable. And Newton's second law is where a lot of marks are. So the object will continue to move in its in uniform motion unless acted upon by a non-zero resultant force. So basically, there isn't much one to worry about Newton's first law. So when you prepare a further, just try to find a multiple choice and maybe the application of inertia. So let's not waste time and now go to basically D, which will be Newton's second law. And this, ladies and gentlemen, out of the 35 that we have there, it will be something like 20 marks. I repeat, something like 20 marks. But what is it with Newton that one must know? One, you need to be able to state Newton's second law. Newton's second law. And it is either 2 or 0, ladies and gentlemen. There is nothing in between. So you must be able to tell us to say when a net force is applied on an object, the object will accelerate in the direction of the net force. And acceleration is directly proportional to F net and inversely proportional to the mass of an object. This is where now you get 2 or 0. There isn't part marking when it comes to this particular law. So it's either 2 or 0 in the exam, So either 2 or 0 in the exam. Very, very, very important. Immediately thereafter, ladies and gentlemen, the expectation will be draw a free body diagram. Draw a free body diagram. Now, here comes a challenge. The challenge is that in Nambane, I am given 2 objects. I am given 2 objects that are now connected by string. Let's make this one a little bit bigger. That are connected by string. And we say now this one is A. Okay, we need a surface for that. Correct science, ladies and gentlemen. We are going to need to have a surface. Let's have a surface here. Half surface. Then I must draw it by hand. Half surface like that. And then we have now force applied in this particular direction. Let me make this force applied in an angle somehow. Force applied in an angle. Now, let's remove this. And now, rough surface. Rough surface. Ladies and gentlemen, it's two objects. The first one is A and the second one is B. Okay, somehow the internet seems to be slow. Let me just connect to another one quickly. Done. Thank you very much. Now, we have object A and B. Ladies and gentlemen, the examiners are not going to ask you to draw for both of them, but we need the 2 free body diagrams in order for us to perform a calculation that relates now to Newton's second law. So the examiner will just say, draw a free body diagram for block A. And this will be now 4 marks. So the hint here will be, if it is now 4 marks, ladies and gentlemen, the expectation is I must have 4 vectors, because every mark or every vector will represent 1 mark. So if the examiner says draw a free body diagram for block A, yes, we are going to draw for block A. But now the catch is, for the purpose of calculation, I am going to need now to have what? To have 2 free body diagrams. So I am going to draw one, which is A, but immediately after that drawing of A, what must one do? Very easy. You need also to draw the second one. I will show you why. As a hint, immediately after drawing the free body diagram, the examiner will either say calculate tension or acceleration of the system. The system now means block A and B. So what is the catch here? Ladies and gentlemen, hint that is very, very important. Hint here is when having 2 objects, use F net is equals to MA twice. Very, very, very important. Use now FA is equals to MA twice. That is now the hint that I am sharing with you to say, once you have two objects, you must use now Fnet is equals to MA twice. That basically says we are going to say now I am focusing on block A, Fnet is equals to MA. I am focusing now on block B. That is now what Fnet is equals to MA. But we are going to run and look for a common factor at the second instance. Let's go back. Draw a free body diagram for A. So what Ntatinambani is going to do is to say, I am drawing now a free body diagram for block A here. That will be now F normal, FW, and this will be my tension force. And because we assumed that it is moving into this particular direction, this is now the direction of motion, and we take it as positive, then I am going to have my FK there. So when it comes to application of Newton's second law, ladies and gentlemen, very easy. Fnet is equals to now what? Tension plus Fk, which is equals to Ma. But now can you see that already it becomes a problem if I do not have a free body diagram that is now correct. Then tension must be positive, friction must be negative, and this just becomes our Fa. Then this will be equation number 1. Just note that I don't have any information. It's just a way of thinking and the best possible way of applying Newton's second law. So I am going to pause also for 30 seconds such that now you can digest this. If you have questions, then I will be able to attend to your questions. So the next 30 minutes, or sorry, 30 seconds is for one to digest and basically think of whatever that Ntatinambani has said up to this particular point. Ladies and gentlemen, thank you very much for you now digesting everything. Can we apply now this to block B? Of course we should. We should be in a position of actually applying this to just sorting out my screen here quickly, sorry. Just sorting out my screen here. There we go, better now. And then transition. Let me quickly go into block B now. When we go to block B, ladies and gentlemen, when we go to block B, there is no way that I can just say Fnet is equals to MA without identifying the forces. So what must I do? Identify the forces. How do I identify the forces, ladies and gentlemen? I identify forces by using now a free body diagram. The examiner only asked for A. I gave the examiner A, where I am going to get my nice 4 marks. But now, how can now I use B or information of B? It becomes very, very complex. Why? Because I did not identify the forces that actually contribute into making this particular system to start accelerating. Why? Because as per Newton's second law, an object will accelerate in the direction of the net force. So that we agreed that this particular system is moving to the right. So what must one do? Very easy. I'm going to say here, this is now for block. Even though the examiner did not ask for that, what must I do? Very easy. Draw a free body diagram. Identify the forces. These forces are going to assist me in order to understand now issues of application of the Newton first law. Second law. Let me quickly do it. This is because the examiner did not ask for this one. I can immediately draw the one with components, ladies and gentlemen. Why the one with components? Because the one with components is going to assist me in terms of the forces thereof, or the actual forces that are making this object to move. Fn, let me have my Fv, and then I am going to have my Fh, I am going to have my Fk, but I also have tension there, and I am going to have my FW. So now, ladies and gentlemen, the object, I am told that it is moving horizontal. Horizontal. So I can only focus, I can only focus on the forces that are doing work horizontally, or that are actually making this object to accelerate horizontal. The object, even if it is now pulled at a certain angle here, pulled at a certain angle here, it doesn't necessarily mean now the object is moving in the direction of the force applied. The direction of the motion is still horizontal. So what force or forces are causing that? It is this force here, which is equals to F now, cos of theta. Then this particular application, ladies and gentlemen, I did not make it up. It is a basic principle of one understanding when working with one object. That is the reason why I said this will look like it does not have any link to Newton's second law. But it does, because the free body diagram of an individual always now influences the amount or the number of forces that actually do work, or that actually make the object accelerate. I want to move away from the word work because it's now for another topic for another day. So ladies and gentlemen, this year, drawing of free body diagram, the actual understanding of FV is equals to F sine theta, FH, very, very important. When is it going to be applicable? When I have a force applied at an angle. This also when a force, it is applied on an inclined plane. Also, these three are the basic principles, ladies and gentlemen, are the basic free body diagrams of one understanding Newton's laws. Why? Because for A, I just applied scenario number 1. For B, I applied scenario number 2. Can I apply scenario number 3? Yes, it means I must just now have an inclined plane. So ladies and gentlemen, let me now use this free body diagram of block B to do what? To say FH plus FK plus tension is equals to MA. Then I'm going to make FH positive because of the choice of direction. Remember, force is a vector quantity, minus FK minus tension. This is equals to MA. Then maybe one can say that the number, let's make T subject of the formula here. It will be FK plus NA or MA plus FK, but in this instance it's going to be FH minus FK minus MA, which is just equals to tension. And this now becomes equation number 1, and this one becomes equation number 2. But what is the meaning of these equations, ladies and gentlemen? Obviously, the examiner must give me some values. The examiner must give me some information that I can work with. Questions, please. Ladies and gentlemen, there's about 124 people here. You cannot necessarily tell me that you do not have a question for me. Questions, please. Learners, everyone, teachers, please, questions, so that maybe I can be able to enhance and explain further in terms of how to actually prepare for the Newton laws. By show of hands, by show of hands, Ayanda, quickly ask your question.
So could you please again explain the yield part, because I'm a bit confused there. Why do we have to use Fnet equals MA twice?
So
Okay. Okay, it's basically easy. Remember, you have now Fnet. Sorry, you have block A and block B. So we treat each block independently. Why? Because the forces acting on A are not the same forces acting on B. So for one to be able to do that, it's easy to say, let me isolate A and focus only on A. Let me isolate B and focus only on B. Then it makes it easy to look for that one common factor. And that one common factor in this instance is going now to be the tension, But because they are connected to one string, it means the tension experienced by A is the same tension experienced by B. Then it allows us to equate the equation and solve for whatever the examiner is going to do. This will be plus minus 6 marks in the next. Maybe your question comes from, but in that number, can't we use a system method where I am just going to combine the mass of the two and divide and do so? No, that is now an old method of using or calculating the tension and the acceleration. Recently, and in the past 5 years up to now, or even 6, we want to see you using Newton's second law equation twice. Why? We isolate A because the forces at A are not necessarily the same forces acting on B.
Okay, so if I use the old method, am I still gonna I'm not gonna get marks for that?
Yes, so let's say this is 7 marks, you'll probably maybe get 3 out of the 7 instead of the actual 7 out of 7. So you are not necessarily not knowing the principle, but you are using a method which is now not necessarily giving you marks, because this is how we will mark this. Noted, blessing, noted. Let's kindly switch off our mics, please. Thank you. This is how we will mark it in a normal paper. This 2 here will be 1 mark. Let me use red, sorry. This 2 here will be 1 mark, either one of the 2, for using Fnet is equals to MA. Then for substituting the mass, it will be 1 there for both of them. Then maybe for the value there and the value there also, and now the final answer somehow. So it will be around 6 to 7 marks, depending exactly on what is now the examiner assessing. But believe you me when I say you will only get a maximum of 3 out of 7 or a 3 out of 6. Even a 3, maybe it's me pushing it, it will be a minimum of 2. So kindly now use this in order for you to isolate block A and block B. Why? Because if you make a mistake maybe on one block, let's say B, it doesn't necessarily penalize you for things of A. That is now another advantage of using FNet twice. I hope you are answered, Ayanda.
Thank you, sir, very much.
Thank you very much. Blessing.
Hello, sir. I'm just asking if, like, what does FV inter means and FH?
Okay, I did explain FV, it's a vertical component of the force. So FV, it's, let me go back for this particular one. Yes, this force is now applied at an angle, this particular force. So we break it down into its components. It is going to have now a vertical component and a horizontal component. But remember, this object is not moving. Let me use petrol. It's not moving most into that direction, this particular object. It is actually moving horizontal. So what does that say? It says there's a horizontal force that is actually pulling this particular object to move into that particular direction. So hence I said now, check, am I working with angles or air forces applied at an angle? If it is a yes, then it means you need now to resolve that into components. For purpose of now what? Calculations. If I'm working with an inclined plane, I must also break it out into its components only for the purpose of calculations thereof. Happy blessing.
Yes, sir. Thank you, sir.
Thank you very much. Ori, how can we help you?
Sir,
Yes.
if we calculate, let's say we're done calculating everything and we get a negative answer, what does that mean?
Okay, a negative answer for what? For acceleration or for tension?
For a force.
For a force. Okay. Then let me quickly go to the next page. Let me quickly go to a next page. The next page is this one. If the answer is negative, it basically says the force it is in an opposite direction with the motion. We are working with vectors. So if we are working with vectors, this basically says what? This basically says, no, I need to have a choice of direction. Oh, sorry. I need to have a choice of directions. Sorry with that. That is the reason why I highlighted here to say the motion is to the right and I choose now my right direction as positive. So what does that mean? It means if I am going to calculate frictional force for FK, not the chances, I must get it now as negative. Why get it at negative? Because it is in the opposite direction with now what? Opposite direction with my choice of direction. So I chose that everything that is moving to the right must be positive. So everything moving to the left must be negative. So it is very, very important for one now to always realize that choice of direction is what is critical. It is what is now important in terms of one understanding exactly how to go about this particular approach in terms of calculations. So it basically means your choice of direction. Your choice of direction is what influences your answer. I think I have answered you, Ori. Are you happy with that answer?
Okay, I understand a bit more.
Thank you very much. It's always a pleasure. Ladies and gentlemen, let's move. If there are no any other questions, what does now going to be another set of questions? Ladies and gentlemen, it will be two objects or even one, we do not know. But if it's one, it basically says apply now Newton's second law once. But the mistake is you not identifying your horses. Fine. After that, we further say, okay, fine. If it's two objects, let's use now FNet twice. I just recently now explained why. So can I be in a position of saying, let me duplicate this quickly in order for me now to check if this strategy, this application, this way of doing things can be of good use or assistance to me. Let me check after duplicating. I'm just going to put now these two objects on an endline link and check if now this is going to actually assist me in terms of the application of Newton's law. I am not interested in the values because the values will be given. It's just an issue of, do I have the right approach? Do I have the right mind of actually following through the question that the examiner is actually asking? So let me just now try to duplicate this and remove a couple of things. Then we can go to E, and then immediately after E, it will mean that we should have now exhausted Newton's laws, because I don't see any funny question coming out tomorrow, honestly, because the application has always been the same throughout. The misconceptions has been the same throughout. So the only thing that we need to do is now us actually applying the basic principles. Ladies and gentlemen, I have sent now the link to the register again in the chat. Kindly complete it. Remember, if your school is not there, the only thing that you just do is to say other, and then it will give you an option for you to complete the form. But this now has taught me that maybe I must go back, modify the form in order for us to be accommodating everybody who's going to join our classes moving forward. My inputs, please, while I am sorting out the duplication of slides this side. Okay, now let number D. It's Newton's second law. So it's now stating of the law 2 or 0, drawing of the free body diagram, a maximum of 4 marks. That is now 6. Then the application thereof will now differ. But the expectation is the application of second law only must be now something like 20 marks or so. So be on the lookout for that. Follow through, and we will be now in a position of ensuring that we get maximum marks. The computer is not responding, ladies and gentlemen. I do not know why. Let me just give it some time. I must just maybe go back here, because now I want to put at E, universal law of gravitation. It can be complex at times when the examiners refer and talk about the gravitational acceleration at a different planet, calculating the height thereof. So we should not take it now for granted as if it is now business as usual. That will not be the case. That will not be the case. It is important to always take everything important and very, very serious. While I am accepting others, ladies and gentlemen, it's 11:33. It means we've been here now for a very long time. We apologize if we could not get to was this other topics. It's only because of the challenges we had. So what I am going to do, ladies and gentlemen, is on my YouTube channel, I have all the content of tomorrow being recorded. I recorded it some time back. So you can check on YouTube under Nambani Academy. I have electrostatics. I have electric circuits. We also have intermolecular forces, atomic combinations, which are part of everything that will be assessed. So long, I just wanted to send you the link to the channel itself, so that maybe if we run against time, then you are able also to go and watch by yourself. That will assist us a lot in terms of the support that we can give you. Feel free now to subscribe. Feel free now to sending it now to the chat. Please, Dr. Doctor, kindly switch off your camera. I have just sent you the link to the channel, so that if we run out of time here because now of the challenges we experienced, I think we'll only do Newton's laws by the way of things, unless if you guys now feel that you can go up to one, but I always feel that it's always important for you also to have your own time for you to work and do everything. So we are not going to extend this session beyond 12 o'clock. And now that is basically just creating time for you to go back home and look into your things, prepare properly, you know where your challenges are at, then you can basically refer to the videos as much as I have sent them the link to the channel itself. And also I'm going to share the website now immediately in the chat. Visit the website. We have previous papers with memos and everything, nice things there for you. So also visit the website. It's now directly in the chat also. Then feel free to visit the website. We'll forever update it and for you to always get nice things. Ladies and gentlemen, without wasting any time, let's go to E. This is now universal gravitational force. Law of universal gravitational force, something like that. What does it say? Basically, first thing here, it's now stating the law. State the law. Very, very, very important. State the law. Very, very important. Stating the law will basically mean when what does it say? I forgot also. It will be now 2 marks, but it says now something like, let me quickly refer so that I give you now the correct one. It basically says something like each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The equation will be given F is equals to gm1 m2 over now r squared. So the expectation here is r squared because it's just now the radius between. It must be now in meters. So it is very, very, very important. And then your mass here must now be in kg. So your mass must be in kg, and obviously this is now your force, and this force must be in newtons. So basically there isn't much here, ladies and gentlemen, but there's another important equation that I want you now to be on the lookout for. This equation is G is equals to gm r squared. So this one now allows us to have this gravitational acceleration. So this gravitational acceleration is measured in meters per second squared. Then this is still our distance, which will be now in meters m, and that now will be the mass of planet, the mass of the planet. And remember now that G is basically a constant thereof. So that should not be a problem at all. It will be just now the application thereof of everything of Newton law of universal gravitation. I want to take questions relating to this. The expectation is we are also going to have a question in multiple choice, and that question in the multiple choice will be referring now to what happens when the R is doubled, what happens to F when R is halved, what happens now when the mass of the particular object is doubled. So all those will now come from the application here, application in MCQ. Very, very, very important. So you need to look for things like half, things like double, and things like that is basically it. Half of what? Half of the mass, double of what? Double of the mass, or half of the radius or the distance between their centers. The distance is being doubled. So this is now keywords that will assist you when working with the multiple choice questions. I have a nice, beautiful question on Newton's laws that I have here. So I'm going to basically explain the question for the purpose of time. For the purpose of time, this is a previous paper. One object is given. So if one object is given, what does this say to me basically? It says that Nambani, when I look into this particular question, there are two things that I realize. I have my force applied, but at an angle. So if that is the case, it means automatically I need to have a free body diagram with the components. The examiner at 8.11 says now draw a labeled free body diagram showing all the forces acting on the crate for 4 marks. So I am going to have the force applied, force normal, Fk, and also Fw. Then I will be able to get the maximum of 4 marks. But for the purpose of calculations, I need now to have the one that I am going to now highlight in yellow for us to actually see that even though the examiner did now ask for a free body diagram, but I need to be in a position of drawing a free body diagram with the components. I will tell you why. Let's look at 8.12. A constant frictional force of 3 Newton acts on between the surface and the grate. The coefficient of kinetic friction between the grate and the surface is 0.2. Calculate now the normal force. Very easy to do. We are given Fk, which is 3, hence the data. We are given mu k, which is 0.2. Then we write the formula as it appears in the formula sheet. Why write the formula as it appears in the formula sheet? Because there is no mark for the manipulation of the formula. If you start by saying mu k is equals to Fk over Fn, that is not correct. You write the formula as it appears in the formula sheet. Then that will be Fk is equals to mu k F normal or the capital letter N. Then we know definitely that you are actually in the right direction of what? Of explaining or calculating the normal force. So it's easy. It is just now a matter of substitution. Sorry, it is just a matter of substitution. 3 divided by 0.2, then you get your Newton as now, sorry, your frictional force as 50 newtons. Ladies and gentlemen, check now what 813 says. It says, calculate the magnitude of F. How can one calculate the magnitude of F? When you look into the free body diagram that we drew here, the one with the red dot, it looks like everything is complex. But when I consider my vertical forces, which will be now Fn, which will be now Fv, which will be now Fw, are they causing this particular object to accelerate? No, because this object is not moving up. It's actually moving horizontal. So what is the meaning of that? The meaning of that is actually FH is the one causing this particular object to accelerate in the direction of the net force. So that is the reason why I'm going to say, but now in this instance, A is equals to 0 meters per second squared. Why, ladies and gentlemen, these particular forces that I am going to work with, they are actually not doing any, or they are not making this particular object to start now accelerating upward. It is only moving horizontal. Questions, please. If there are no questions, then it says, I know F normal calculated is 15. FV is what I am looking for. The reason for me to look or calculate FV is very easy because I know the relationship between FV and the F, or the magnitude of F. So like we said, FV now being a component is just F sine of theta. So if I can be able to calculate the magnitude of FV, sine of theta, which is 20, I already have. So if I can be able to get FV, then ladies and gentlemen, this should be an easy approach, an easy way. That is the reason why now FW, using those basic principles from the free body diagram here, FW we know is just equals to mg, is just equals to mg. M, where the mass is the 2 kg, and the 9.8 now is the gravitational acceleration. Calculate for V. V is equals to FV is equals to 4.6 newtons. Then use that rule of components to say, but now I know FV is equals to F sine of theta. And with that being said, ladies and gentlemen, it makes it easy to know that F sine of 20 is equals to now 4.6. Divide both sides by sine of 20. Eventually, you get now your answer as 13.45. So this is an easy way, an easy approach in terms of the application of Newton's law. The identification of forces is very, very important. Questions, please. If there are no questions, ladies and gentlemen, let me give you now the 30 seconds that you deserve for you now to digest everything. And I will go now to 8.2 quickly, such that we can be in a position of ensuring that we understand. Let me look into, there's a hand here. It is Nhlapo Nomakhoba. Questions, please. Or inputs for that matter.
Hello, Dade.
How are you, May?
I'm okay. So I was asking if you could just leave a link of a previous question paper so we could use them.
Okay, I have just sent the link, the address to the website, which is www.nambaneacademy.com. When you get there, it becomes easy. You just now go under question papers. You will see it will tell you grade 11, grade 12, grade 10. The memos are also there. And also you can either go to content material. You will get now all these e-notes that I have. So visit the website address. I gave it in the chat. It is www.nambaneacademy.com. And other lessons also are available on YouTube. While you are on YouTube, you guys know this thing. Just search for the Nambani Academy, and then you'll get everything that you are looking for. I don't see any other hands. And Nhlapo, are you covered?
Yes, sir, I'm covered. Thank you.
Thank you very much. Then, ladies and gentlemen, Sebabatso Lihoko.
Hello, sir.
How are you, brother?
I'm good, and you, sir?
I'm doing well.
Sir, may you please just explain your substitution into the Fnet equals to MA?
Okay, Fnet is equals to MA. Now, let's look into the free body diagram. Do you see we have two free body diagrams? The one that I'm going to give to the examiner, the one with the red dot. And then there's this other one highlighted in yellow. But that I am not giving to the examiner. It's only assisting me for the purpose of calculations. Why? Because it has now all the forces that are actually doing or making this particular object to accelerate. Like I said, the force is applied at 20 degrees, but that object is not moving at 20 degrees. It's moving horizontal. So FH is actually the force that is making it to move horizontal. Rough surface gives us now what? FK, happy with the horizontal forces. FA is now applied at an angle. So if I break it down into its components, I am going to get FV and FA. But now Fn plus Fv plus Fw, they give me now what? All the vertical forces. But this object is not moving up and down. It's moving to the right because of the force applied at 20 degrees. So the actual forces that are making this particular object to start moving, it's what? FH. But now, if I am going to use FH to calculate for F, it means I am going to need to have the acceleration. Let me maybe write it down here for you to see. If I am using Fnet is equals to MA, Fnet is equals to MA, and considering horizontal forces, this will be FH plus FK is equals to MA. But you see where the challenge is. Acceleration not given. So already this will not assist only because of acceleration is not given. If I want to consider the horizontal forces, but I said fine, The horizontal forces, yes, are making it to accelerate. But how about I can use now the vertical forces, which will be Fn, Fv, Fw. But now, is this object accelerating upwards or downwards? No, it is not accelerating. Then there basically means there is no acceleration being done by the vertical forces. Then that becomes a 0, and everything multiplied by 0 becomes 0. I hope it explains and answers your question, Mr. Sebabatso Lehoko.
Yes, sir. Thank you, sir.
Thank you very much. It's always a pleasure. Ladies and gentlemen, it's exactly 17:57. I just want to quickly check if we can get reflections of today. I don't want us to go beyond 12, ladies and gentlemen, because I'm one person who believes you must sit down and also try and study. I am looking for somebody who can give us a reflection of today. If you feel that you have something to say about today's session as a learner, feel free to do so, maybe by show of hand. I will give you an opportunity for you now to say something. It's just a pity that we did not cover majority of the topics only because of the challenges we have. So unfortunately, ladies and gentlemen, it basically says next time when we prepare for such, we must just ensure that we have now all the resources in place to assist us. So I'm quickly just going to randomly choose anyone to give us the reflection of the day and maybe messages of good luck for tomorrow. Lesedi Katari, kindly open your mic and now give us the reflection of the day.
Okay, so today's lesson was very helpful because obviously Newton's laws is a very complicated topic, but with more practice and after this lesson, I believe that I'll be able to apply it when I'm writing.
Thank you very much, Lesedi, and all the best for tomorrow. Memalahlela, I don't see Mezapi. Can you kindly maybe give us a message of good luck and thank the colleagues and learners that are in this particular platform?
Mr. Nambani, before Meza, please
Yes,
remember our announcement. Just
yes,
talk about it.
Can you go on to it maybe, please, so that we can be able to give Mezapi the platform, or she's not in the meeting network. Yeah, she's not in the meeting. Then let me maybe do the announcement. If I'm missing it, Emma, you'll also assist. Ladies and gentlemen, this is the first of many to come. It was actually just a trial system to see what we need to do to improve in terms of giving you all this support. So this is an initiative from Motao District in the Free State by Emma, and that is Rahume. So you will be getting more of this kind of lessons to prepare you, but because the content is so big and a lot of needs to be done, so just, I don't know, Emma, those that are in Gauteng, you'll basically send the messages through TPE and everything.
No, what we'll do, they just have to check the website. We'll put the programs on the website. And then, because, but we'll still extend the invitation. It's not only Gauteng, there's also Limpopo in here, there's Mpumalanga, there's Eastern Cape, Northwest. So we just extend the invitation like I did with their PSCs and the subject advisors, but we also put everything in the website. So they must just visit our website just to check what is happening, because the plan was to at least every week. If this week we are dealing with grade 10, the following week it will be grade 11, then we'll be discussing the content for term 3. So it is going to be an ongoing thing from now until even next year. The ones who will be in grade 11, we will still continue with them. Okay. So we did not want to close it to the grade 3 state learners only, because we want all our learners in the country to perform.
Very,
The invitation is extended to anyone.
very, very clear, Emma. So colleagues and learners, as Emma says, there's a lot of programs happening, but now remember, we work also for the Department of Education in the Free State. We are subject advisors, we do all these things, but we saw that now there's a need. So next time, maybe it will be easy for me to invite Ntates Harume to my studios here, such that he can use all these nice gadgets that you have, because now you did not complain about not seeing the writing, you did not complain about the screen not being clear. So it basically says it's just a way of us improving. So be on the lookout. The website, again, it's nambaniacademy.com. We are available on YouTube, Nambani Academy. We are available on Facebook also. Like us and follow us under the Nambani Academy. Everything, it's Nambani Academy. So it basically says those posters that Emma or the program is referring to will be up there for you to see when is the next this kind of a session. It will be up there, definitely. I will put it up. And the other thing is, if there are videos also, I will put them up in the channel. So the only thing that we want you or need you to help us with, kindly just subscribe. There will be more to come. Tell a friend who was not here. Let's assist one another, because your support will only basically mean more content for you and support for everybody. So be on the lookout for the program. Fortunately enough, we have now colleagues at DBE, different provinces, because we work as a collective. So the message will definitely be distributed to the provincial subject coordinators and then distributed to schools via your teachers, and then you can easily get the link. So from me to you, thank you very much. Let me quickly now take Keisha.
Sir, will you kindly please give us the links for past question papers?
It is in the chat, sir. www.nambaniacademy.com. I will send it again in the chat. Ayanda.
Sir, I was asking, is there like a WhatsApp group where like every now and then you could communicate to tell us that, okay, this week we have a meeting or something like that?
I had a WhatsApp group for such, but it ended up becoming a lot of messy things, because it was everybody in the country. So it's sometimes somehow very large and complex to maintain, but maybe I will see if I can do it. So let's basically just say, let's start now this relationship of working together through the platforms that we already have. Then we will extend when we see that now maybe communication is so clear, such that we can have now people joining from wherever they are through the WhatsApp and things like that. So let's just for now say we will look into it.
So how can I get notified every now and then that there's a meeting like this? Like you said,
how did you get this one today?
Oh, well, I got it from a school teacher in my school. She
Definitely.
So
the teacher will basically now get the link the same way they did today. So just be on the lookout that your teacher should now be sharing the links with you. Don't worry.
Okay, so thank you very much.
Thank you. Emma,
Can I just come in there? What we're going
please.
to do, we're going to draft the program for the whole term so that all the learners are aware, everybody is aware when we're going to have a class. So the only thing that we will send later, it will be the link. Okay, so just keep on visiting the website and check when are we going to have the grade 11, because we have to remember balance, we have grade 10, 11, and 12. So our main focus now is 10 and 11. So just check the website. We'll set all the dates and then put them on the group, on the website for the whole entire term until you write your final exam. Okay? Then the links you will get them from the teacher like you did today. Thank you.
Thank you very much, Emma. Ladies and gentlemen, I don't see any questions. I don't see any hands. I think we have exhausted now this particular session. But like I said, ladies and gentlemen, it's a learning curve. It was now our first time actually broadcasting to so many people in the country. So if there were any challenges, bear with us. But it is only a system that we can improve. As basically you can see now, things are a little bit better. So follow us, join us, subscribe, tell a friend, do all this now nice things of basically assisting the person next to you or someone who's doing the physical senses. Mezap is not in the meeting, so I will just say thank you, learners, thank you, colleagues. Let's meet on the next one as the program will be drafted, and good luck for the exams that you are going to have either tomorrow or during this particular week. From me to you, thank you very much and have a lovely day.
I think Mezap is not in the chat anymore. Thank you, colleagues. Thank you, learners, for joining these classes. Hope to see you again in the future. Thank you, Tate Nambani. Thank you, Tate Sarume. All the colleagues, all the learners. Hope that we learn something, gained something that will prepare you for the junior exam. All the best. Thank you. Bye.
Thank you, Emma.